Well, good morning to the 4 people that are listening to me today. Let's just start by someone in chat confirming that they can both see and hear me, just to be sure everything is going according to plan. Oh, now there's no one listening to me. Oh, she's back. Or he, I don't know. Oh, there's more people. Welcome. You made it. I'm just looking for confirmation in the chat that you can both see and hear me.
I can see and hear you.
Oh, perfect. I'll just turn you up a little bit. You're very quiet. Okay, good. Let me just get a page going here, and then we are ready to go. All right. Now, last time, which was Friday, you had the task of starting the discussion on Babylonian arithmetic, where we're going to do the same thing as we did with Roman numbers, which is we've done the conversion. Now we want to do addition, subtraction, and multiplication within that number system. Now we will briefly review the addition and subtraction by way of an example, and then we still have to do multiplication, and that will be that. So let's, whoopsie, what is happening there? Oh, my pen works. Addition. Let's just make an example because the long weekend might not have been good for my memory. So it's good to just remember what did we do last week? So let's make an addition question and feel free to ask questions and make comments as we go. This is not the time to be quiet. It's not. Okay, so let's make it maybe like that, and then a space, and let's make this one nice and big. My tens are never pointy. I need them to be pointy. And let's make this one maybe like that. And then we will add a little bit. Let's add maybe like so. And let's add that. And there we go. That's as good a question as any to practice our addition. Now, of course, our method doesn't change, whether we're looking at Roman numbers, whether we're looking at Babylonian numbers, whatever we're gonna be faced with the rest of the week. It's still starting with the ones column. Now, I have 29, and I have to add 43. Now, of course, I can't go and write here 29 plus 43 or anything. I can't do it. Not allowed. I will lose any marks I might accumulate in the quiz if I write any number that is not within this number system. Now, of course, you have your calculator, but it's nice to practice in my head as well, and then maybe we can get confirmation. Uh, so what did I say here? 29 plus 43, so 29 plus 40 is 69, plus another 3 is 72. So let's maybe just see that in the chat. Something to look at. I can't write it down, but I want to see it. 72. There it is. Now at least I can look at it. See. Okay, well, 72 is too big for this spot. I have to carry over one group of 60, and then I'll be left with 12. So that one doesn't look great. See if we can at least make them look the same. Then I move on to my next column, which is the 60s column. Now, in truth, what we're doing here is one group of 60 plus 54 groups of 60 plus 21 groups of 60 is a certain number of groups of 60. But because we have this groups of 60 attached to absolutely everything in this column, we don't have to say groups of 60 every single time because it's everywhere. So instead, we just say 1 plus whatever this is on its own in isolation, forgetting the position, the column that I'm in, which makes the method much more efficient in that I could be 5 places in and I'll still say 1 plus whatever plus whatever. But it's not actually a 1 here, it's one group of 60. It's very important to understand that because when we teach our addition with place values in elementary school, sometimes they ask, well, you say 1, but I'm in the tens column. How does that work? No, it's not really a 1. We just say it. So what do I have in my column here? 1 plus 54, that's 55, plus another 21, that's 76. Maybe I want to see the 76. Maybe I want to do it on my calculator for confirmation because I'm not too confident with my mental arithmetic. Whatever works for you. Let's do that. 1 plus, what did I say here? 54 plus 21. And I see my, whoops, 76. Now I can think, okay, 76. That's again one group of 60 relative to this column. That's a group of 60. It's really a group of 60 groups of 60. And then I have 16 left over. Now I can move to my next column, which is just 1 plus 12. It's not really. It's one group of 60 squared plus 12 groups of 60 squared equals 13 groups of 60 squared. But because that's literally attached to everything I'm saying in that column, we stop saying it. It's always there. It's always there. And depending on the audience, I might need to emphasize that. Or if I'm just doing it for myself, I should remember what I am actually doing and how the method works, what the method is doing, why the method allows me to do it the way I do it. Look at each column in isolation as if it's the ones column. It's not the ones column, but the method allows me to make the whole addition simpler by looking at pieces in isolation. Any thoughts or questions about addition? I don't know how easy or
It
difficult it
seems
is. Yes,
if we can make sure that we compartmentalize it properly, it seems fairly straightforward. But I think I'm going to get hung up on the different groups of 60s. But we'll see how the test goes.
yeah, I mean, and there's time. The I like to focus on what's different and also on what is similar. And there's a lot of similarities. Yeah, it doesn't look like it, but once you start staring at it and working through some examples, there should be a lot in terms of the method being the same, except in appearance and in the fact that we're counting groups of 60 instead of groups of 10. Other than that, it's the exact same method. So I think there are more similarities than there are differences. Just the differences are visual and they're sort of distracting and seem much worse than they are. But hopefully with enough practice, and I mean, uh, it's hard to say. It's hard to say how much practice you might need, right? Everyone is different. Don't skip practice if you need it. And you'll know when you've done enough of these, it becomes quite straightforward and sort of mechanical because that is what the method encourages, actually. The method encourages me to stop thinking. And if I've done enough, that'll happen automatically, which is now why we have to go into these other things because in the decimal system, that has exactly happened. We've stopped thinking, and I kind of need to think. So we're in this mess because of the method. It's too efficient, it's too good. So let us set up a subtraction. And again, like I did for the Roman numbers, I want to think of the worst case. And then anything I come across later on can't be that bad because I've already understood the worst case possible. So let us do something like this. And we'll subtract. Maybe we subtract, I don't know, 22. I don't know. We can make this one a little bigger if you will. Let's say here 40. Feeling okay, 6. It's fine, whatever. Doesn't matter. There we go. Can we do it? Now, I don't know. I assume everyone worked through the video in their own time, paused, rewind, watched, did whatever they needed to do. And if you didn't enjoy that watching the video portion or being forced to something, just let me know. If you have any issues, any recommendations, any suggestions, all of it. I want to hear it all whenever you feel like doing it. So now, what is our method saying? Our method is still saying go to the ones column, do the subtraction there in isolation. However, in this case, I have nothing and I need to take away stuff. Can't be done. So I go look at my next column to borrow for this column, but there's nothing there to borrow. So I need to go to the next column to borrow for this column, middle column, in order to borrow for the ones column, which I actually am in. So a little bit of a stepwise procedure here. So I'll make it blue. Blue. We need to borrow for the not tens column. This is the 60s column. I am always borrowing 1. Sorry, that wasn't quite clear. I'm borrowing this guy. Come to me. Now he's gone, and he splits into, or it, or she, or whatever, splits into 60 groups of 60, because this was 60 squared. Now I'm just going to list the 60 as 6 tens, because, oops, that was way too early. Pointy 10. Because I think it's a good middle ground to not worry about the actual representation, but just see the collection of stuff that I have here available once I've done the borrowing. I'm just pooling it together. Now I'm thinking worst case, right? Because you've already supposedly done some subtraction. So we're ready for this, I hope. This should not be the first one you see. Now I have some stuff and I want to borrow. Let's go pink. I want to borrow. Let's go up here. I want to borrow for my ones column. What do I borrow?
60.
I always borrow one group of 60. So in this, I'll erase my arrow in a second. In the 60s column, I'm borrowing one thing, and that will become 6t or 6 tens. So it's like one little baggie I want to borrow, and that splits open into 61s. Now I just put some pink stuff in the wrong place here. Hold on. Let me back it up. So I don't see a 1 though. I just see tens. So I'm going to have to take one of them. Let me zoom in. Zoom. I'm going to have to take one of them and say, look, buddy, I don't want to see a 10. I need to see some ones here so I can take one of them. So let's get rid of this guy and just write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I will then borrow that 10. Sorry, borrow this 1. Whee! And he's the guy that splits up into 61s. And he is now gone, leaving me with 59, and there was nothing else. Yeah. The only difference is I am counting in 60s and not 10s. That's the only difference here. Now let's zoom back out. Whee! Come on, go back to get away from pink now. There we go. Now I'm ready. In my ones column, finally, 60 minus 46. 60 minus 46 should be 14, and I will write the 14. Or do it on your calculator, doesn't matter to me. The ones column is finally done. Whew, that was a lot. And I'm thinking this is now the worst case, right? Chances are you won't get this that bad, but I have to be ready. Now, like I said, for my 60s column, I have 59 minus 22. 59 minus 20 is 39, minus another 2 is 37, and I can represent that. 37. 1, 2, 3, 4, 5, 6, 7. And then I can move on to the 60 squared column, and there's only one left. Oh, poor guy. And I'm done. Easy peasy. Sort of. Not really. Can be. Everything gets easier with practice. It's just a question of how much practice. How much practice. Now, of course, I know you have practiced all of this already over the long weekend, and I'm probably boring you, but I have to do it anyway. Any thoughts or questions about this, other than why am I torturing you with Babylonian numbers? Subtraction. I know, speechless. The first section was speechless too. I don't know if it was because it was super easy or it was super complicated. Don't know. Because there's a lot of similarities. There are more similarities than there are differences in this method. I think way more similarities. So yeah, there it is, subtraction. Then of course we have to do multiplication. And as you prepare yourself mentally for this task, I will be right back. Just give me 1 second. Well, more than 1 second, but I'll be right back. As you think, if you have any questions on the first two, because we don't want to move on to multiplication if the addition and subtraction aren't solid yet. And we have the time. I'll be right back. right, we are back. Did you realize you had any questions, or are we ready for multiplication?
No, go ahead. Multiplication.
All right. Now, let's see here. I have these exercises that we might as well do. I didn't want to copy other exercises that were already covered in the video, but this one is, I think, new. So we have A, B, and C. So lining these up are pretty straightforward because we're going to keep the second number nice and small, just a single place. So we have 4, ooh, that's a very curvy 10 there. 49 it looks like. Ooh, that's going to be fun. I need to practice anyway, maybe. Then I have a 10, no, 12, not 11. Okay, times. I have a time symbol. That's nice. And this time we're going to multiply by 5. That should be fairly straightforward. We can have any single place number just to keep things sort of in check. Now, we are following the same method. Nothing changes, which means we're going to go to the first column. And I say it backwards just out of habit. 5 times 12. Now 5 times 12 is 60. I then represent the 60, which is one group of 60 and nothing else. So in the case of the Roman numbers, we did the same thing. We said the multiplication. Am I frozen?
You might be.
Is my head moving side to side? On my screen it is, but I can't see exactly. It's hard for me. I can't tell.
I think you're frozen.
Frozen, frozen? Okay, hold on. Let me disconnect and share my screen again. Okay, let me write something on the screen. How's that?
That's better
Okay.
for me anyway.
Yeah, no, just let me know. I can't tell because it doesn't, excuse me, it doesn't even show me a preview of what it looks like. So, in case you missed it, we say 5 times, we in this case have 12. 5 times 12 happens to be 60. I then write the representation for 60, which in this case is one group of 60 and nothing else. But we do the same thing as we did in the Roman number case and really all of the cases. We do the multiplication, we say the multiplication in English. Can anyone else hear me? Man, technical difficulties all over the place.
I can hear you.
Okay, okay. We do the multiplication, we say the multiplication in English, and then whatever that answer is, we represent it in our number system. We did the exact same thing with Roman numbers. If my answer happens to be 60, well, then I represent 60, which is a two-place number, move on with my life. So it just looks strange, perhaps. It is the same method. I then move on to the next column. I do the, well, now I'm going to be in this column here, right? I'm going to start over here, which means I'm going to pad my answer with quote unquote 0 because I have that symbol. In the case of the Roman numbers, we just had empty space and we just had no option. There was no empty place symbol. But in this case, a part of the representation is this empty place symbol, so I need to have it there. Empty space is not the system. It's not the number system. So we then say 5 times 49. Now, really, it's 5 times 49 groups of 60 is a certain number of groups of 60, which is why I start in the groups of 60 column. But there's absolutely no need to say groups of 60 after every single thing I'm going to do. So we simplify it. The method encourages simplification to just focus on a smaller multiplication. Well, smallish. 5 times 49. Now, perhaps you want to practice doing that in your head. I like to take the time and practice it. But maybe you don't have a lot of confidence. You can also use your calculator. I just can't write any decimal numbers on the page at all. But I can sort of cheat it by using my calculator, of course. So let's maybe see that if you need it. 5 times 49. So you have that in front of you. Of course, we knew it was 245, but it's nice to look at it as well. Then we see, well, oh, this is way too big for a place here. I don't have that option. I can only go up to 59. So 245 is 4 groups of 60, making 240, and 5 left over. And of course, it's relative to the column I'm in. I can say that. Then, so because we're working in groups of 60, the numbers in a single place can be a little big. Use your calculator if you need to. That's totally fine. I like to take this time to practice some mental arithmetic because I have to force myself or it's not going to get better in any way. Now I'm moving on to the third column, which means my answer is going to start in the third column, which means I know the other places for that portion is going to be empty. And I then go 5 times 13. 5 times 13. I know everyone knows it's 65. But just to show something in the chat, to have something to look at, maybe it helps us. Maybe you want to keep everything in your head. Regardless, you can't write 5 times 13 equals 65 on this page. 65 is too big, so I'm going to make one group of 60 and 5 left over. Then I'm adding all of this, the second phase of the method. Ones column, nothing. Next column, something, but not much. 6. Next column, 4 plus 5. Of course, it's 9 because it's so much fun to draw all these symbols. And the next column is just a 1. Whoop, whoop, done. Let me zoom out and see the whole thing. And there we go. The method does not change. The method does not change. We're only using Babylonian numbers as a stepping stone to work towards our decimal system, to better understand it, to see it for what it is, and know every single part of it, so that any question little Timmy can possibly ask me, I am ready for. And I'm ready for it with confidence, and that confidence gives confidence, transfers to him, that fights anxiety, all those good things. But it starts with me perfectly understanding what I am doing. All right. We have 2 more. Let's do them. The B1 I have in front of me. I'll just copy it over for you. 3 places. I have a 25, it looks like. Then I have an 11 in the next place. And then I have a 5. And I'm multiplying that by 7. Because why not 7? And there we go. We are ready. Start with the ones column. 7 times 5, 35. That can fit, no problem. So that's a good start. Then, when I move on to my next column, I know my answer is going to start in that column, padded with an empty symbol, empty place symbol. Then I'm ready to go. It is 7 times 11. That is 77. That's too big. 77 is one group of 60 and 17 left over. Is everyone okay with that? We have to be okay with it, or we need to ask. I guess it's that easy. All right then. Then the next column, I'm going to start in that column, which means I'm going to put my empty places, which you're welcome to see as zeros, in the columns leading up to that column. Then I will go and say 7 times 25. Is that right? 25? Or it doesn't look familiar to me right now. It's fine. This is what it is. Doesn't matter. 7 times 25. You can do it in your head. You can do it in your calculator. It doesn't matter to me. It's up to you. 7 times 25. 7 times 20 is 140. Plus another 35. So 175. Maybe you like to practice mental arithmetic like me, but you're also not super confident, sometimes like me. Then use your calculator. It's okay. 7 times 25. Confirmation is always nice. And then I can see the number. I just can't write the number here. 175 is too big. I need to make groups of 60. That's going to be 2 groups of 60. Very close, almost 3, but only 2. Using 120, leaving 55. 5. Now I'm ready for the addition phase. And it's pretty much just moving everything down. There's not a lot happening in the addition usually. I have my 35 at the top. Make sure you bring everything down. The next column, second column, is also just bringing everything down, which had 17. Next column adds a little 1 to my 55. That doesn't change it too much. And I have 56 and then the 2. So the addition rarely has much to worry about. Just make sure you copy everything down correctly. And another one is done. And with each one, I feel better. I hope. I don't know. I hope so. Remember that tomorrow, because usually people need some more time with Babylonian numbers in comparison to Roman. I've scheduled an open Q&A session during our class time for you to use however you want to use. Use it, don't use it. Ask about Roman numbers, ask about anything you want. The time is there for you to use how you want. If you're good with Babylonian numbers, then take a break, relax. We have the time, why not? Okay, next one. Last one. Ooh. Let me write it down. We have 15. We have a space. We have 20. We have a space, and we have another 20. Then we're multiplying by 10. Remember, 10 is a single place number. It's in the ones column, right? All right, so I start. 10 times 20 is 200. 200 is too big. 200 is 3 groups of 60 and 30 left over. Now I'm doing less. I'm not showing the calculator, etc., to see, for you to see where you're at. But of course, you have all those things as little helpers. So stop me at any time. It's okay. Then I'm going to the next column, which means I'm going to pad it with an empty place symbol. Then I'm ready, and it happens to be the exact same, 10 times 20, even though I know it's not. It's 10 times 20 groups of 60 is 200 groups of 60, which is why I start in the groups of 60 column. But I can relax that and say 10 times 20 because it's all relative. That's what the method helps me to do. 200, that's again 3 groups of 60 relative to this column, and 30 left over. Then I move on to my last column from the right, pad it with empty place symbols, and I'm good to go. Then the last one is 10 times, what is this? 15. 10 times 15 is 150. That is 2 groups of 60 and, I don't think I did this right, but no one is saying anything. Anyway, let me do this. Let's finish this one. 10 times 15 is 150. That's 2 groups of 60, giving me 120, 30 left over. Did I do all this right? No one is saying a thing. I'm not doing it for me, I'm doing it for you.
I think so.
Let's just run through this again. We have time, why not? I suspect I did something wrong. Let's pretend it was on purpose. First, let's go from the start. I said 10 times 20, right? That's 200, right? 200 into groups of 60. That's 3 groups of 60, which makes 180. So there's only 20 left. It's tricky because I can't see the numbers. Now, of course I can. I can put it on the calculator. No, not like that. Sorry. Maybe like that. 200. So if you want to see the 200, it's right there. You can see, okay, well, if I take 3 groups of 60, that's 180. That only leaves 20. And I accidentally said 30. Of course, on purpose, just to test you. Of course, I would never make a mistake. Then we move on to the middle column, the exact same thing, 200, 3 groups of 60, making 180, and there's only 20 left, right? And then the last one was 10 times 15, which is 150. 2 groups of 60 make up 120, so 30 left for that one. Yes? Maybe? Sometimes, if I say so. Right. Then our addition is, I think, pretty straightforward for most of the multiplications. And we have just our 20 here that we corrected. And then we have 23. Try and make them nice and pretty. I don't like how detached these are, but it's okay. Then our next column, 33. And then the 2. Done, done, done. So yes, because of the 60 in a single place, the numbers can be bigger, which with multiplication could present a higher chance of little mistakes. Use your calculator, do whatever you need to do to be confident. Again, my goal here is to stay within the number system, to not convert to decimal, do the multiplication and convert back. That I learned absolutely nothing. I've already done conversion. This is a new kind of question. Same as for Roman, there are 5 things we need to be able to do: convert back and forth, addition, subtraction, multiplication. Only 5. And then we will move forward in history a little bit towards the decimal number number system that we know today. Any thoughts, questions, comments, criticism?
Just to clarify, we're not supposed to convert when like doing the arithmetic, but it's okay for the multiplication to look at like here we did like 10 times 20, and that's how we found that.
Yeah,
And that,
no, we're still saying everything in English. We can't actually convert to Babylonian completely here. It's really just visual in a way. So when you do the multiplication, whether it's in your head or a calculator, we're still, of course, converting little bits of it
yeah,
for
and
our
that's
language, of course, yes.
okay.
But it's not a
Cool.
full conversion and then the multiplication and
Right.
then a conversion back. There is a difference. But because of the way we speak, we can't completely uh, transform to Babylonian arithmetic. That'd be too much to ask, yeah.
Right. That makes sense. Thank you.
Any other thoughts or questions? Maybe tomorrow. Think about it. We have the time. Use the time however you need. Other than that, we will stop there until tomorrow or the next time we see each other.
Thank you.
Thank you.